Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Mr. Kadim Khan and I am a lecturer in the Institute of Computing, Quart University of Science and Technology. Today we will take lecture number 24 of the subject of software quality engineering, in which we are going to discuss the software quality metrics part 3. And here our topic will be the process and product metrics for software quality. Dear students, this is the third part of this topic. This was very vast topic, so that's why we have divided it into three different parts, and this is the final part. In this part, we will, in fact, discuss different other techniques for software quality measurements, and these are another sort of the matrices. So in this lectures, we are thoroughly discussing these techniques. This is the discussion agenda. It contains topics of software system failure density matrix. Then we have the failures of the maintenance service matrix. These metrics are in fact used for the identification of different errors during the software development, that is in the programming phase and during the maintenance phase. Then we have the software system availability matrix. This is also a matrix in which when we maintain the software and is measuring the availability of the systems. Then we have a complete process of defining software quality metrics. This is very much important. It will help you how different steps will be used and what are these steps to measure the software quality. Then we have general limitation of the quality metrics. Here we will discuss different problems or limitations that may occur during the measurement of software quality. Here are different examples of the matrices and also another examples of the matrices. There are certain other metrics which we cannot place it in any category, but these are also very much useful matrices. And at the end we have the exercise. So this is very much important to do certain numerical exercise at the end. Now we have very much important types of matrix that is called software system failure density matrix. The software system failure density matrix measures the density of the errors that can fail the project or the software. So there are three different important matrices of the failure density matrix of software systems. First one is called software system failure density. Software system failure density measures the density, that is the ratio of the failures when a software is being used. So here SSFD, which is software system failure density, is equal to NYF divided by KLMC. Here NYF is the number of software failure detected during a year of maintenance. So when we maintain the software for a particular year, the number of errors occurring is called NYF, number of software failure detected during a year of maintenance. It is divided by KLMC, while KLMC is thousands of lines of maintained software's code. So all that code which has been maintained during that particular year is in fact years counted in thousands of lines of code. So SSFD is equal to NYF divided by KLMC. Next important matrix is called weighted software system failure density. So here we will in fact also identify the weighted software system failure density. Now weighted software failure system density is equal to WYF divided by KLMC, while WYF is in fact the weighted number of yearly software failure detected during 1 year of maintenance services. So here we will identify the weighted value of the in fact the density errors in the one particular year, and it is divided by 1000 lines of maintained code for that particular year. Next one is called weighted software system failure per function point. Here the per function point is a particular function values or particular functionality which is in fact failed, and then the system has been maintained. So weighted software system failure per function point is equal to WIF divided by NMFP, while WIF is equal to weighted number of yearly software failure detected during 1 year of the maintained services. So this is in fact the same as like in the value in the above matrix, while here the divisor is NMFP, which is number of function point designated for the maintained software. So all uh, full code is not in fact considered here, just that particular code which has been maintained, and it is in fact here's the weighted number of that is the number of function point designated for the maintained software. Here we will consider the function points, while the function point is the particular functionality of the software system. Now, students, as you know that it will give us certain values. So you have to think that what should be the ideal value of these particular matrices. For example, SSFD, which is the software system failure density matrix, is equal to NYF divided by KLMC, while NYF is the number of failure detected during a year of maintained services. Now clearly, if the above value is becoming larger and larger than the below this values, that means that the value will be in fact the full value provided by this matrix will be more than in the fraction. For example, it can be 10.5 or 25 or more than, for example, 1000 point something. So, and if this the above value is smaller than the below value, then it will give us the values in the um, in the less than 1, for example 0.5 or 0.8 or 0.3, 0.2. So when it tends to 0, that means that the system is more successful, and when it's becoming more than 1, that for example 500, 600, 700, that means that the system has a poor quality. Okay, now failures of maintained software services matrix. Here we will provide the services of the systems when that software is maintained, and during that maintenance the failures may occur. So there is just one matrix here, that is the maintenance repeated repair failure matrix. So maintenance repeated, when we repeat the maintenance and repair the system, what sort of the errors are occurring and what is the ratio of these errors. So all these problems are identified by the maintained repeated repair failure matrix. Here MREPF, that is the maintained repeated, means that during 1 year or during the particular year, when the maintenance is repeated over a number of times and still the software is failing, so we will use this matrix here. So MREPF is equal to REP, that is repairing, YF divided by NYF, while this value is the number of repeated software failures call. So when we call again and again to the help desk that this system is failing, and for this particular period of time it has been failed, then we will count this value, that is REPYF, which is the number of repeated software failures called or services failures, and it is divided by NYF, while NYF is number of software failure detected during a year of maintained services. So the above values is in fact representing the particular calls when the software is failing, and the second value, that is the below value, is used in fact it counts the failure detected during a year of maintenance services. So how many times that particular failure is detecting here. Now, another types of software matrix is the software system availability matrix. Software system availability matrix measures the availability during the matrix, during the life or during the maintenance of the software systems. So first matrix here is the FA matrix, which is the full availability. Full availability means that the software is fully available with us and there is no certain problems during the usage of the softwares. So here full availability FA is equal to NY SERH minus NYFH divided by NYSERH. So here NYSERH is the number of hours software system is in the services during the 1 year, while NYFH is the number of hours where a last one function is unavailable. That is the field. For example, last one function that is the unavailable are filled during 1 year, and it also includes total failure of the software systems divided by NYSERH, while NYSERH is the number of hours software system is in a service during the 1 year. So here all hours are counted for the particular years, while NYFH is counted the number of hours when the last one function is unavailable. That means that how much time has been taken when the last function in the software that is the unavailable with us. So that is the FA full availability matrix. Second one is the that is vital availability. So here the vital availability is very much important, which shows that how the software is available in the vital time. While vital availability is into NYSERH minus NY vital FH divided by NYSERH. So here NYSERH is the number of hours software system is in the service during 1 year, minus NY vital FH means that the number of hours when at least one vital function is unavailable are failed during 1 year, including total failure of the software system. Similarly, it is also divided by the same values as in the above. So this one matrix is in fact counting the vital availability of the software systems, that how the software is more vital, that the vital functions which are very much important function in the software system, they are filled and they gives us the wrong values. So what will be the quality of the products when the vital function get filled? Similarly, we have TUA matrix, that is total unavailability. This matrix is used for that product when it suddenly fails and it fails forever. So when it gives us particular values and that values based, we in fact identify that the software has been failed totally while using the system. So total unavailability is equal to total unavailability matrix is equal to NYTFH divided by NYSERH, while NYTFH is equal to number of hours of total failures. Number of hours of total failures means that when completely the software has been totally failed, and how many hours that software has been failed for one particular year is equal divided by number of hours software system is in a service during the 1 year. So that means that here it counts number of hours of total failures during the 1 year divided by number of hours software system is in the service during the 1 year. So in fact, when this value is, when for example 1 divided by 1 is equal to 1, for example 20 divided by 20 is also equal to 1. So when it gives us the same values, for example, so then it means that the maintenance and the failure capability and the maintenance capability of the softwares is in effect equal. That means that software has been maintained as like the same number of time as like it has been failed, and when its values is becoming more than 1, for example 20, 30, 50, 100, then we can say that the software's quality is very much poor. And when it is less than 1, for example 0.5, 0.3, 0.2, etc. are equal to 0, then it means that the software is of the high quality. So software process for defining software quality matrix is very much complex, and this is in fact a simple steps. These are different sort of simple steps which is used to define the quality of the software products. So basically, first of all, we will define an attribute to be measured. So before conducting the measurement, we have to identify different attributes of the software system which we requires to measure. For example, the attributes may be the efficiency, portability, security, etc. So we will first identify an attributes of a software which requires to be measured. Then we have defined the metrics that measure that particular attributes. So here we will identify a certain matrix. These metrics will in fact measure the particular attribute which we have identified are defined in the step 1 here. For example, here we can use MTTF matrix, etc., or any other matrix here. So we can identify certain matrix, and that matrix should be relevant for that particular purpose. For example, if we are measuring the process, then we will identify the process matrix here. So here we will identify, for example, if you are measuring the staff turnover or the productivity of the programmer, then we will use that particular matrix here. Then we will determine the comparative target values, that are the indicators. Indicators are certain values which gives us insight into the particular analysis. So indicators are in fact the certain values are the numerical values which based on that particular indicator we take certain managerial decisions that whether we have to continue with that project or we should shift that products to or that project to another organization or to another technology or to the group of another software engineer. So here we will determine comparative target values. Comparative target values are those values which are our expected or our desired values. For example, we want that the software should not fail. So here we will identify different comparative values. So the comparative target values are in fact those desired values of the matrix, which we think that using that particular values will gives us a good quality attributes of this particular projects. Next one is number 4, defining the methods of reporting and matrix data collection. Here we will identify or establish a certain techniques which will be used for reporting. Reporting means that to take different response from the community, including the developers, including designer, testers, and maintenance people. Similarly, including the end users, we will identify different reporting techniques, and also we will define the matrix data collections. So here we will also identify the what sort of data will be required for us that will be used as an input for the matrices. So here we will identify different matrix data collection techniques. Next is number 4, software quality, metrics, procedures, and work instruction. Here we will in fact identify different techniques. Through that we will in fact measure the matrices. So software quality metrics, procedures, and work instruction includes different step-by-step plans and techniques. Based on these techniques we will compute the matrix. Next we have the applications of software quality metrics. Here we will in fact identify that the applications of software quality metrics include different tools which will help us to calculate the metrics. So here we will identify different software metrics applications, and these tools will be in fact automated tools. Now, if our matrices are successful, then matrix data collections, then we will, when all these in fact steps are successful, then we will collect the matrix data. So here we will in fact, when that application will be in fact installed and it will be conducted and executed, and the data will be in fact provided to that software applications, then matrix data collection has been performed here. So here that means that the output of the matrices are here will be certain documents or formulas, and these formulas will be the numerical values here, and these values will be used for the managerial control application. Means that the manager will use these values, and based on these values the manager will control the full products or full projects here. Now if that particular values is not satisfied or the manager is not satisfied with that particular applications, means that then the manager will take another steps here. So that means that all these steps will be improved. So step number 2, 3 and 4 will be improved here. So matrix part analysis of matrix performance means that we will analyze the performance of the matrix here. That means that if there are certain question marks over the matrix, then we will in fact conduct these three phases so that they give us exact and accurate values of the matrix, and these values will be in fact free of any sort of the errors. So analysis of the matrix performance and effects of environmental change means that we will analyze the matrix, and also we will analyze the performance of the matrix, and effects of environmental change means that when there is certain environmental changes occur in the organization, the environmental changes are not the climatical changes. This means that the changes in the managerial, changes in the tools, technologies used for software development, and also used for the measurement of the matrices. So we will in fact identify different sort of the environmental changes while conducting the quality matrix measurements. So here we will change of matrix, make it may requires that the matrix can be changed. For example, if we have wrongly selected certain matrix layers in the first steps, so then we will reconsider this matrix, or we will change the matrix and we can use the new matrices here. So then with changes in comparative target values, here means we can also change the indicators here, which are those values which are the target values. Then we can also make changes in the matrix data collections. For example, there is a problem in the data collection for the matrix. We will update that methodology, or we can use certain new methodology. For example, if the questionnaire has not worked, then we can conduct the interview for collecting the data. So that means that we can change all these three steps so that we get the good quality matrix. And also in this steps, development in the organization and its environment. So we can also get data. In fact, we will get data from the all the development teams in the organization and its environments. For example, the environment may include the hardware and software environment or other resources which are used for the software development. So we can we will take that information here and we will update these three steps there, and we will again conduct the software quality matrix procedure and workflow instruction. That means that all the procedure will be conducted here and the work instructions will be performed. Then we will provide that data to the application of software quality matrix. Means that there will be certain software tools which will perform the measurement of software quality matrix. Then these matrix data will be collected and they will be properly documented into one or more documents. And then these, based on these values, the manager will take the decisions to control the application or they control the project. So this was a very thoroughly and procedural steps used for defining the quality matrix and conducting the measurements. Now we also know that there are certain limitations of the quality matrix. The limitations are certain drawbacks of the quality matrix. If these three drawbacks are existing, that means that the matrix values are the matrix quality is not of the high marks. So that means that they can affect the decisions here. So we must have to compute the quality matrix in a very good care for. So first, general limitation of the quality matrix is the budget constraints. Budget constraints is in allocating the necessary resources. So budget means that we require measurements of the quality matrix requires high budgets. So if there is low budget for the matrix collections or matrix computation, that means that we cannot conduct a good quality matrix shares. For example, in our country, there is census. So census requires budget. So if the value or the resources required to compute the census are not so much as it should be, so that means that the results will be here of not that type which we are expecting. So quality matrix requires good budget shares. Second one is the human factors. Human factors also affects the quality matrix. So for example, those people who are responsible to compute the quality matrix, if they are less skillful or they are less educated or their experience is not proper, so then it can affect the measurement of the quality metrics, especially the position of the employees to evaluation of their activities also affect the human factors. So that affects the quality metrics. Third one is validity. Validity means that how we can be sure that that value is valid here or that is true value. So validity is the uncertainty regarding the data's partial and biased reporting. So that means that if there is certain biased reporting in the collection of the data or there is certain uncertainty in the data, that means that there can be the question marks over the validity of the matrix here. Now here we are going to discuss a few examples of the matrix. First one is the requirements matrix here. These matrices which are used in the requirements collections. So the number of requirements that change during the rest of the software development process means that if we are collecting the number of requirements, that means that the whole our software requirement analysis team is efficient for collecting the requirements of the products. So if a large number of changes during the specification, designs, or coding, testings, and maintenance, etc., something is in the wrong in the requirement phase, and the quality of requirements engineering was. So means that if there are certain large amount of changes are occurring over the specifications, designings, implementation, testings, coding, and finally the maintenance, that means that the problem is on the requirement side. So requirement must be collected in a great care. Secondly, that the less changes of the requirements, the better requirements documents quality. If the customer is not changing the requirement documents or they are not frequently changing in the documents, so that means that our requirements document are of the high quality, or the procedure used for collecting the requirement is of the high quality. Next one is the inspections matrix. Inspection is the testing. In fact, here that the inspection teams perform the validity or verification of the software system. It is the number of faults found during the inspection can be used as a matrix to the quality of inspection process. So during the inspection process, if the number of faults are occurring during the usage of the softwares, then the inspection team will use that particular matrix for the quality of the project. Next one is the in fact testing itself. So number of tests executed is also one of the example of the matrix. So how many tests are executed in a particular year of time. Similarly, a particular period. Number of bugs found per thousand line of code is also one example of the matrix. Similarly, and more other possible matrix here. These are all examples of the software quality matrix. Maintainability matrix. Maintainability matrix include total number of faults reported during the maintenance of the softwares. Classification by severity fault types. Here, all these faults which are very much severe or medium severe or low severe, that means that what is the particular the strength of the fault. that is identified here. Status of the fault reports reported are fixed. Here we will identify the status of the fault reports, whether this fault has been fixed or still that fault is existing or it is not fixed here. So we will identify the fault reports here. Detection and correction times means that that particular fault is detected and then that fault is also corrected and that particular time is measured here and that measurement becomes as a examples of the matrix. Reliability quality factors. Here we will count the number of system failures, system down. So count of number of system failures means that how many times that particular system is down or failed in a particular period of time. For example, in 1 month, how many times that system has been failed. Total of minutes divided by hours per weeks or months. So here we will identify the total of minutes divided by hours per week or hours per month here. So how many minutes the system is up here is totally divided by hours per weeks or hours per months here. Here is the examples of the matrix here which we will in fact perform as the types of the analysis. So when we have to analyze the matrix or we are going to analysis, then we will in fact identify different groups of programmers and that based on the performance of these particular groups, then we will make certain managerial decisions. So programmer productivity using error severity and density matrix. For example, we are going to consider error and density or error severity matrix here. So assume that we have three levels of severity. First level is called low severity errors and here its weight is 1. So weight is the particular value which is provided to the severity values. For example, low severity value is 1 while the medium severity value is 3. Similarly, very high severity weight for the particular error is 15 here. So that means that we have three different severity weights 1, 3 and 15. If we have two different programmers which are producing 3000 line of code per day. So 3000 line of code is per day is the two different programmer capabilities. Now after inspecting of these the performance of these two programmers, so we have identified that one that is 100 low severity errors occurred for the one programmer, 20 medium severity errors and 10 high severity errors are occur in the code for the programmer 1. So that means that 100 low, 20 medium and 10 high is the performance of that particular programmer. And another programmer has 300 low severity errors, 10 medium severity errors and 2 high severity errors in the code of the programmer 2. Now, if I ask a questions from you that which programmer has the highest quality code, means that which programmer of the two has performed a good coding. So how you will identify? So this is very simple questions. So you need to multiply the weighted values of these three different types of severity errors with the corresponding values of the performance of the programmer. For example, for this programmer, which is the programmer 2, 300 is the low severity errors and the value of the low severity is 1. So 300 multiplied by 1 plus 10 multiplied by 3 which is 30 and similarly 2 multiplied by 15 which is also 30. So 300 plus 30 is equal to 360 values. Similarly, for that programmer, we will also multiply it. For example, 100 multiplied by 1, similarly 220 multiplied by 3 and similarly 10 multiplied by 15. So 100 multiplied by 1 is 100 and 20 multiplied by 3 is equal to 60 and 10 multiplied by 15 is equal to 150. So when we will in fact perform the calculations here, then you will get one answer here. So based on that particular value, you can decide that which programmer is efficient or good in coding. So you have to compute it by these values through yourself. and maybe certain questions were asked in the exam papers about these metrics. Now there are also another metrics, for example, understanding metrics. So understanding metrics means that learning time. That is the time required for a new user to learn the software systems. That is the to understand the to learn the system. Ease of learning means that the learning time also the time for new user to learn how perform basic function of the software. So this is for the new user, this is for the old users. For example, already if the user has in fact used certain functionality, then for example learning time is the time for user to gain basic understanding of feature of the software. While here it is a time for a new user to learn how to perform the basic function of the software. So this is just for understanding, and this is in fact the matrix used for learning the software. Second one is the operability. Operability means that operation time required to perform by the user. So time required for a user to perform certain operation of the software is operation time. Similarly, we have the usability. Usability is the human factors, means that how that particular system is easy or to be used by the particular human. So number of negative comments from a new user regarding or ergonomical human factors, etc. So uh, these are in fact certain negative comments, and we count all these comments about the system by the user. Also, we have number of types of defects found during requirement design, code, and testing. So already we have discussed all these things in a very much details. Number of pages of documentation delivers, that is number of pages produced during the software development. Number of new source lines of code created if we are maintaining the software, and we are in fact performing updation in the software. Then we have to code the new source code in the software system. Number of source lines of code delivered to the end users, number of source lines of source code delivered, total number of source code delivered, average complexity of all modules delivered. Similarly, average size of the modules. Here, all these metrics counts the number of line of code in the software. Similarly, total number of modules are the units in the software projects. Total number of bugs found as a result of unit testing. So here we will identify different types of bugs and faults that are in the software products, and these are in fact act as a unit testing for the software system. Total number of bugs found as a result or during the integration testing, when we perform either top down or bottom up integration, then we also faces certain bugs. So these bugs are totally counted and are identified, and they are properly counted and documented. So total number of bugs found as a result of validation test. Validation test is the final test, which means that when we have to validate that the software is performing exact operation as anticipated by the end users. So that means that in the validation test we can also identify different sort of bugs. If these bugs are found, then we will document all these bugs, and these bugs, number of bugs will act as a matrix for the software system. Productivity as a measured by kilo line of code per person hours. As we already discussed, kilo line of codes means that as code that will be executed, it can be it can be also executed code in the software system. That will be the productivity of the programmer. So how many thousand hour line of code has been created by the person or a programmer in a 1 hour or per hour unit of time. Similarly, we have metrics for analysis models. Here, these are certain matrices which are very generalized matrices. So, all these matrices which are used to analyze the model. Model will be the particular model of the products. For example, the GUI model or database models or design models. So for analysis of that particular models, we will also compute certain metrics here. Metrics for designs model. When we design the GUI, so how many components are in fact used here? What is the relationships among these components? How many text boxes radio buttons, etc. And if we are designing the GUI, for example, the database systems, how many tables and their relations, how many primary keys, how many secondary keys, all these are counted and these are act as a matrix for the software system. Matrix for source code. So here we will identify different source code matrix here. For example, line of code, 1000 line of code is one of the source code matrix. Similarly, productivity of the programmer is another source code. Average find and fix cycle times. That the average times find and then fix cycle time is also another examples of the software matrix. We have already discussed the maintenance matrix here in our previous slides. So these are different sort of metrics which will identify certain errors, and then these errors are fixed there, then these are also computed. Number of person hours per inspections. So number of hours spent on the inspection of the software system are counted here. Number of person hours per kilo line of code. So number of persons means that number of people that have worked for the 1000 line of code in terms of the hours. So how many hours are spent on the particular 1000 line of code of the software project. Average number of defects found per inspections. Here we will identify the average of the defects found during the inspections. Similarly, average find fix cycle times means that if we fix the particular values for particular errors, then we identify that here. Number of defects found during inspection in each defects categories. Here we will count the number of defects that are identified by the inspection teams for each defects categories. The defects category may be, for example, medium defects categories, high defects category, or low defects category. These are in fact certain categories which define the severity of the defects. Average amount of rework times. So here we will identify the average of the rework, that is implementation or redesignings or reanalysis that we have performed. We will identify the average amount of that particular time. Percentage of modules that were inspected. So number of modules that has been inspected, we will count the percentage of that modules. Now, dear students, in the last we will perform certain exercise for you. These are for your skill developments. How can you measure the quality of the project manager skills? The project managers have different sort of skills. For example, report writing, report presentation, similarly scheduling, planning, and costings, and similarly staff selection, staff evaluations. All these are the skills of the project managers. You have to make sure that how different techniques are used for the measurements of the project manager skills. Requirements documents, how you can measure the quality of the requirement documents. This is also for your task here. And similarly, software development plan, how we can create the good quality plan using metrics. How we can create user manuals. User manuals are certain helpful manuals while using the software system by the end users, for example help files. Similarly, we have programmer coding skills, how we can identify or count the programmer coding skills there. Similarly, how we can measure the quality of the design specification. Design specifications are certain specs which are used for designing, for example, database specifications. Similarly, we have the UML specifications, graphical user interface specification. Similarly, we have certain graphic specification, network specifications, which are different specifications used when we will design the softwares. For example, different components, they will be required to integrate with each other and they will pass data from one component to another component. Then what will be their specifications? So this is just for your thinking here. It is not your assignments, but it is just to use your mental strengths, that how you can think about these problems and how these problems can be solved using the certain quality matrix. Dear students, this is the end of the lectures. These are two good books which will help you to study more about these matters. The final book is very much important here, Computational Intelligence in Software Quality Assurance by Scott Dick and Abraham Kendall. So these books contains different other types of metrics as well, but I just covered here the quality metrics. So if you want to study more about certain metrics, you should study these books. Also, if you have questions, you can ask this question through the email. My email is n.kadim@kust.edu.pk. So I will wait for your question and will respond immediately as soon as I get them. Thank you very much.